Hey guys, this is Miss Martin, and this is everything that you need to know about covalent bonds. So, unlike ionic bonds, in which one atom needs to lose electrons and the other one needs to gain electrons in order to fulfill that octet rule, covalent bonds are instead between two atoms that both need to just gain electrons. So, because of that, they're going to share those electrons between the atoms in order to fulfill that octet rule. Quick reminder, so the octet rule just says that all atoms would like to be the noble gases in that eighth column of the periodic table, and they would all like to have a full outer shell. That is like the highlight of you have like arrived as an element if you have a full outer shell. You are living the good life. So, covalent bonds are really only going to form between nonmetals. So, if we think about what our periodic table looks like, and just a second, I'll drag one over. Then all of our nonmetals are over in this section, the sort of teal, green, purple section. And all of those nonmetals are going to bond together because all of them, like nitrogen, oxygen, fluorine, etc., and all of these green guys right here, are really, really close to having that full outer shell. For instance, fluorine is just one valence electron off from being just like neon in terms of energy, in terms of that outer shell. And once it gains that extra electron, it becomes a more stable compound. So it goes from being a really reactive element by itself to a really stable compound. So it's just going to either bond with an ionic bond, is where it forms a bond with something over here in order to gain its electron, or it can also bond with itself. So here's what that would look like. So if I have, oh gosh, that was bad. Okay. If I have fluorine, I'm going to try the best I can here. Then here are 6 and 7. Okay, so this is the Lewis dot structure for fluorine. It has 1, 2, 3, 4, 5, 6, 7 valence electrons. Where did I get that? Because it is in the 7th column. So if I count across, it's 1, 2, 3, 4, 5, 6, 7 columns. So fluorine has 7 valence electrons, and now it's perfectly welcome to form an ionic bond with something that has 1 and just steal its electron from it. But fluorine could also bump into another fluorine. All right, let's try this again. It's a little bit better this time. 1, 2, 3, 4, 5, 6, 7. And I'm going a little out of order here just so I can show this a little bit better. So in covalent bonding, we're going to have two atoms. A lot of times they're actually going to be the same atom. And they're going to take that lone electron, that electron that's just sort of floating by itself. We're going to draw a circle around it. Not a very good circle, that's okay, to show that they are being shared. So fluorine here is sharing this fluorine's electron. And now each fluorine is going to basically count the other's electron as being a part of its octet. And it's sort of saying here, hey, if we stick really close together and form this nice covalent bond, then I'm willing to say that that electron is like, it's like co-owned right now. Fluorine in this case is like, it's like a bad breakup, but they're like trying to share like the pet, essentially. We're going to go with that analogy. So these fluorines now have 8, as far as they are concerned, valence electrons, and as long as they stay like this, F2, fluorine 2, then they can say that they count as a stable compound. All right? So I find that covalent compounds are a little easier to understand. Atoms can share more than one pair of electrons to create even double and triple bonds. So this kind of looks like this. So fluorine and all the other halogens, as well as hydrogen. Don't forget that hydrogen is a non-metal, even though it's over on the metal side. It's sort of a weird exception. So they're only sharing one pair of electrons, because remember, hydrogen just has one. So each hydrogen brings one valence electron to the table, and they're going to share those, and it'll make it seem like it has 2, which is more like helium. And we like to draw a line showing those shared electrons. So this is a single bond. And then here's oxygen. So if we look over at oxygen, it has 6 valence electrons. 1, 2, 3, 4, 5, 6. Wait, that's not right. All right, someone screwed up the thing for oxygen. Yeah, okay, not crazy. So oxygen has 6 valence electrons. Oh, they're counting it as that. Okay, that's weird. Either way, oxygen's going to share 2 valence electrons left by itself, and they sort of reorganize these to show you better. And because it's sharing 2 different pairs of electrons, we call this a double bond. We replace these with lines. And then nitrogen here is kind of the same. So if I draw out nitrogen, it would be nitrogen with a, here, let me bring over my thing again. You know what, let's just make a new one. So if I bring over nitrogen, I'm just gonna go to Scribble. We're gonna try this a little bit better. Hey, okay. All right, and there are, I wish there was just a big dot. Why is there not a big dot? Okay, whatever. Go back to Scribble. Okay. Why isn't it clicking on Scribble? There we go. All right. Technical difficulties. So nitrogen has 3, 4, and 5. So each one has that many, has 5 valence electrons. So each of them has an oxidation number of -3. So they each need to gain 3 electrons in order to become a more negative particle and fulfill that octet rule. So it could either gain 3 from something or it could share. So it's going to share that pair of electrons, this pair, and then this one that's a little hard to do, but just bear with me here. That pair of electrons, we're going to draw like a lasso. And is this the most artistic ability that we are using to show here? No. But it is a good representation of how nitrogen is going to use 3 different pairs of electrons to share. And when I draw it, it's going to be like this. And nitrogen. Okay, not great, but it is what it is. All right. So far, this slide, by the way, tends to freak people out, but it is okay. So far, we have only talked about what happens when a covalent bond, when an element bonds with another copy of itself. So what I just showed you guys, N2, O2, all of those H2s, so everything on this previous slide is called a diatomic. So the word prefix di, di, just means 2, and then atomic just means atom. So diatomics are just 2 of the same atoms, 2 nitrogens, 2 oxygens, 2 hydrogens, bonded together. We recognize these as hydrogen gas, oxygen gas, nitrogen gas. However, you can also form polyatomic ions, which is where you have different compounds that are going to bond with molecules from different atoms, and they tend to have a charge on them. Now, this whole list of them, we're not going to do too much with. We might occasionally talk about them, but we're going to save them for regular chemistry. Instead, there are certain polyatomic ions that I would like us to pay attention to. Let's get past this. Okay, and that is a few that we care about are methane, CH4, carbon dioxide, CO2, and then we'll talk a little bit about how specific combinations of carbon, hydrogen, and oxygen are really the basis of all living things and the molecules that make us up. And then last but certainly not least, I'm going to have to click a lot to get there. There is one polar covalent bond that we care about more than any other, or a covalent bond we care about more than any other, and that is water. So in my next video, I'm going to talk specifically about water. And I believe that is it for covalent bonds. So make sure you've gotten some practice modeling covalent bonds, being able to show, don't forget that you're circling those shared electrons, not drawing an arrow this time, and that you are also showing at the end the line that represents the shared pair of electrons.